this video, we will look at another discrete probability distribution called the geometric distribution. We will use this distribution to review all the concepts we have learned so far about PMF, CDF, and expected value. This will give us the opportunity to see how these concepts can be applied to a new probability distribution and how they can be used to solve problems related to this distribution. So let's get started. The geometric distribution models the number of trials needed to achieve the first success in a sequence of independent and identically distributed Bernoulli trials, where each trial has two possible outcomes: success or failure. An example of a geometric distribution would be the number of times you need to flip a coin until you get heads for the first time. Mathematically, the PMF of the geometric distribution is defined as follows. Here, P of x equals k is the probability that the first success occurs on the k-t trial. The parameter p is the probability of success on each trial. If we plot the PMF of the geometric distribution, we will see that it is a right-skewed distribution. This is because the probability of success decreases as the number of trials increases. Why? Because the more trials you have, the more likely you are to get a failure before a success, as per the definition of the geometric distribution. The CDF of the geometric distribution is defined as follows. Here, f of x equals k is the probability that the first success occurs on the k-th trial or earlier. Plotting the CDF of the geometric distribution looks like this. Since CDF is the cumulative probability of the PMF, the CDF of the geometric distribution is a monotonically increasing function. The expected value of the geometric distribution is defined as follows. Here, E of x is the expected value of the random variable x. The expected value of a geometric distribution represents the average number of trials required to get the first success. Let's take an use case to understand the geometric distribution better. Suppose you are a quality control manager in a factory that produces light bulbs. You want to find out how many bulbs you need to test on average before finding one that is defective. From the previous data, we are told that the probability of a bulb being defective is 0.05. You are asked to find the least number of bulbs you need to test before finding a defective one. To solve this problem, we can use the geometric distribution. Specifically, we can use the expected value of the geometric distribution to find the average number of bulbs we need to test before finding a defective one. Recall that the expected value of the geometric distribution is given as E of x equals 1 over p. Substituting the value of p, we get expected value of x equals 1 over 0.05, which equals 20. Therefore, on average, you need to test 20 bulbs before finding a defective one. This is the end of the video on the geometric distribution. I hope you have learned something new today. In the next video, we will look at indicator, random variables, and how they are useful in calculating expected values. Thanks for watching.